Researchers from the University of Michigan have created a prototype medical device that can capture cancer cells in your blood. The technology is currently available, but it's about the size of an oven and often imprecise. This new prototype is worn around your wrist and plugs into a vein to improve diagnosis as well as treatment. According to the researchers, tumors can release more than 1,000 cancer cells into the bloodstream in a single minute. Right now, doctors rely on blood draws, which can come back without any cancer cells, even in patients with advanced cancer. With this new device, you would spend a couple of hours in the hospital and it would screen a larger sample of blood. In early testing, on dogs, the wearable device collected nearly 3.5 times as many cancer cells than a blood draw. The researchers compared it to security cameras. The old way was like a security camera that takes a still every 5 minutes. The new way is like a video feed. Next, the team hopes to increase the blood processing rate and start human trials in 3 to 5 years. The European Space Agency is currently using two-armed 3D printing. Yeah, it was enough to pull me in as well. But NASA's counterpart across the pond is currently using twin robotic arms that work together to 3D print and mill a test version of the optical heart of ESA's Athena X-ray Observatory. When it's done, it will be the largest and most complex object ever 3D printed in titanium. And if you can dispute that, well, email me. A photo, maybe some video. The robotic arms are currently making a test version of an optic bench about 3 meters in diameter. The first robot uses DMLS technology to build by melting titanium powder. The second robotic arm then immediately cuts away any imperfections using a cryogenically cooled milling tool. The bench itself is placed on a slowly moving 3.4 meter diameter turntable. ESA is currently working with the Fraunhofer Institute for Material, and Athena's final optic bench design is still up for some debate. Scheduled to launch in 2031, the Athena mission will probe up to 100 times deeper into the cosmos than previous attempts. In order to make that happen, the optic bench will align about 750 mirror modules, each of which is formed of 140 industrial silicon mirror plates stacked together by a sophisticated robotic system. And the smallest imperfection could spell disaster. Researchers from the California Institute of Technology, or Caltech, want to limit the devastation after terrorist attacks and industrial accidents cause explosions. For example, the researchers used the 9/11 terrorist attacks on the Twin Towers as an example. When the planes crashed into the buildings, it was substantial, but it's possible that the buildings could have withstood the impact. However, the fuel on the planes turned to a mist, which ignited, exploded, and ultimately brought the towers down. After the attack, the researchers considered that a small amount of polymers could stop the fuel from misting during a high-speed impact. The team created mega supramolecules, ultra-long polymers that have in tests shown the ability to make fuel safer. In one video, they only added about 0.3% of the polymer to Jet A fuel. They took 1 ounce of fuel and simulated a 140 mile/hour impact. The results are astonishing. If you can't tell, the giant fireball on top wasn't treated, and the tiny little fireballs on the bottom were. And all this took place in about 1/8 of a second. The researchers have spun out the startup Fluid Efficiency to bring these mega supramolecules to market and provide samples to petrochemical companies, lubricant producers, and pipeline operators, among others. I mean, it seems particularly relevant, especially as the second chemical fire in 2 weeks just killed a worker in Texas. Now, as for the cost, the polymers would add 1 to 2 cents to the cost of a gallon of fuel. But the hope is that through collaborations with groups like the US Army, they can continue to drive the cost down. I'm David Manti. This is Engineering by Design.